Okay, so you see the screen. This is what you saw, and I'm going to start on the second page first because it seems a bit easier. Right, let me get my pen. Okay, so when I see this molecule, right, this is where's my pen? Hello. Oh. Okay, so when I see the reagents here, ozone, zinc, and H3O+, these two means that I'm going to get a ketone or aldehyde from an alkene. So when I see alkene here, I just cut, and then I insert the oxygen, right? Same for the other side, I pull apart the double bond and I insert the oxygen. So after step 1 and step 2, I'm going to get the carbonyl group, the aldehyde in this case. Next step, part 3, this is a good oxidizing agent. This is potassium dichromate 6. You can oxidize your aldehyde into carboxylic acid because I have heat and reflux all the way. So this is ethanol, which means that it will be oxidized into ethanoic acid. So F must be your ethanoic acid or acetic acid, vinegar, you know. We went through in class, right, in my lecture. So this is the structure of ethanoic acid, F. Now next step is a very strong reducing agent, lithium aluminum hydride. It is able to reduce the carboxylic acid back to its alcohol. So 2-carbon alcohol will be known as ethanol, which is X. And then later on you see X appears again on the first page of the question paper. For compound P undergoes a reaction with SOCl2, thionyl chloride to give you an acid chloride. So we know that on addition of SOCl2, the Cl replaces the OH. So doing backwards, you just copy the same thing, but this time around you replace the Cl with OH. Everything else stays in place. You see, so this is P, right? Now back to front page. Always read the instructions carefully. Question 1 says, draw the structures of compounds A, B, C, D, E, F, M, X, Y, and P on the last page of this booklet. So this is not the last page. There was a section for you to draw in the boxes, right? Only the last page of this booklet will be marked. If you draw here, I can't, or the examiner couldn't mark you right. Show stereochemistry if necessary. If more than one stereoisomers form, draw only one of them. Each structure worth 2 marks. Do not write mechanism. Maybe help you understand, but then we won't give you marks for these, okay? So once again, when I react something that has a hydroxy group with PCl5, I'm just going to exchange the OH with Cl. So A would be my acid chloride, ethanol chloride. Ding ding, that's all. This is A. And then you see a halogen carrier in the next step with a benzene ring, bromine group, right? Bromobenzene. So this must be a electrophilic substitution onto the benzene ring. So what happens is, right, this very good halogen carrier will cut off this halogen part, and then whatever is on here will just be hooked on to this ring. But then the question is, Br, right, you have a lone pair of electron, which means that this is ortho para-directing. Remember my hack I told you during lectures? So you can do 2 positions here or there, right? But I told you that every box you just draw one structure. Which one is it? Later on you see that the clues will guide you over here saying that I'm going to have 1,4 substitution. So we know that the product we want for B must be a 1,4 substitution, right? So you could put the Br here in place, don't change it, and then the 4th position, what do you have? You have the ketone, right? You see? That's it. And next, remember X? X was your ethanol, the one that's safe for consumption, the one that we all drink. Okay, some of us drink, okay? H plus catalyst with alcohol, you know that this must be protection of aldehyde or ketone. And indeed, we have a ketone here and we have alcohol, so we know that it is a protection of it. Remember the alien thing, right? Two eyes and then it connects. So it doesn't mean that you only need a diol to protect it. You can also have two of the same alcohol. You see, I will just draw this. Okay, this is fine. It is protected. This is the acetal. So even if you think that, okay, there's not much of X there, never mind. You can draw a hemiacetal, okay, semi-protected. Why not? Okay, so let's move on. But the thing is, right, I told you C has this formula, so this is the hint or clue. So we know that it can't be your hemiacetal. You see? This is how you work backwards to confirm it before and after you connect it through retrosynthesis, through analysis. So let me draw this for you again. C must be your structure like this. Dun, 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 dun. Okay? So this is protected. And then next we add Mg. Think of what? Grignard, exactly. So Mg with BRO. So this guy I'm putting here as C, it is acting as a Grignard reagent. So this will cut the bond here and insert the Mg inside, right? Okay. And then it's used to attack a ketone or aldehyde group. In this case, it's ethanol. So it will add nucleophilic addition and then hydrolysis. You get back your alcohol. That's how you get this. You see? So this part here, I just put a red line. The new bond form is actually this one. Okay? Don't be mistaken, it's this part. Okay? Next, this molecule here is subjected to compound Y, pH 5, and then I give you the structure. Now, it's just a little meme that I put for you. It's a simple rotation. Some of you wrote like, how can you throw some reagent that can convert a ketone back to a secondary alcohol and at the same time convert a secondary alcohol to a imine? You know, you can't. There's no such thing. You need at least two reagents at two steps. One reagent can't do that. So basically, right, this part is being converted to here. Do you see? Whereas here is actually identical, no change. So you just need to rotate the molecules. You know, sometimes you rotate the paper or rotate the head, and you can see it. What happens is, I taught you in class, this is a nucleophilic addition hyphen elimination, right? So nitrogen is a better nucleophile from an amine. You just have to take a look at this part, crop it out, put H2. How do we know? Remember when I have this right in the tutorial question? This will attack the ketone aldehyde group, and then you take away this water, condensation, and then the nitrogen just join, forming double bond. See that? You can replay this part later on if you are not sure. You can rewind. So this part is done. And then next you subject it to hydrogenation. Platinum again, clues given to you. So we know what really happened. There's an increment of 2 hydrogen atoms. It must be from the imine. You get the amine. So you just draw this for us. And you get a happy ending. Okay, for D. Great. Then let's move on. So D, right, undergoes excess ethanol, Freudian slip, propanoyl chloride. This is acid chloride, and I put excess for some reason. There must be a reason in everything we do here, because there could be one position in the whole molecule that can react with this acid chloride. And indeed this is true because we have both the hydroxy group, the alcohol, and the amine. So both can undergo condensation with your acid chloride. This is acid chloride, yeah, very reactive. Remember, under the acid derivative is right at the top. Very reactive because the bond, CCl bond, is very weak. So both these two atoms can act as the nucleophile, can kick out the Cl and form something new. So the amine will form an amide or amide with the acid chloride, and the alcohol will form an ester. So both parts will react, and then you just draw 1, 2, 3. Okay, please no chemistry faux pas you commit in this paper. Some students count wrongly the number of carbon, hydrogen, when you draw formate this, right, this is actually a 3-carbon ketone. If you put this H here, this is a 2-carbon aldehyde. So there's a difference. Don't just draw like this and think that this is a methanol. It's not true. This is a third butanol. You want to draw methanol, you should put down this triple H, right? It's legendary. So back to here, you draw the structure of the amide and ester. You see O, then ester 1, 2. You see 3 carbon here. So this is your E. And when you match it up, it's the same formula, right? So then this part is your basic hydrolysis. You cut all the polarized bonds here, which tells you it is your, oh pardon, I make a mistake. It should be amide, forgot, 1, 2, 3, like this. Okay. So undergo basic hydrolysis, you cut this amide and ester bond, and then you try to acidify it little by little. You get back this guy, you see, the original one, which is same as D. So this is actually D. If you notice, it's a giveaway. It's the same. If you notice, right, you can verify. So that's all for this question. I hope you had an amazing journey here learning and learn from here. Okay? Remember, you try your best. That's what really matters. Next time, just focus on study hard, okay? It doesn't mean that you put in your best effort, you will rewards. But I'm very sure that if you don't put in effort, you will not get any result. So what you can do is spend time, spend effort, do your best, and then just see how it goes. Okay? Do not be disheartened. All the way. Fighting. Thank you very much. I'll see you next time then. Cheers.
サルボボいえ忍者がいます Hey hey let's go 進化する大切なもの Protect my balls どこが悪い So let's fighting Let's fighting loud